Hey, hi and welcome back. So this is basically the last video of three-part series, and in previous two parts we actually discussed the reverse polarity protection diode. We also discussed the input and output capacitors value and how exactly they came, and in this video we are going to discuss the power LED section. Okay, so now let's start with this video. So you already know the learning objective of this particular video. We are going to discuss the power LED part of the power supply circuit. Okay, so let's discuss the power LED part and let's complete this particular video now. So this is basically the power LED section of the power supply circuitry. So once the system is powered, or once the circuitry is powered with the external 12 volt, this particular IC is going to generate plus 5 volt at this point. Okay, and because of that this particular LED will get switched on. Okay, and this is actually the part number of this LED, which is actually from light on. So that's basically the manufacturer of this particular LED, light on. And the LED that we are going to use, it's going to be a red color LED. Okay, and after that this is actually the current limiting resistor. So wherever we will use the LED in our circuitry, there we have to actually use a resistor, and this resistor is called as current limiting resistor. The reason is it's actually going to limit the amount of current which is flowing through this particular LED. If you don't connect this resistor, then this particular LED will get damaged. Okay, that's the reason you need to connect a suitable value of resistor, and based on the value of resistor that you will use here, the intensity of the LED will be decided. Okay, so in this video I am going to show you how to calculate the value of the resistor that we are using here. Okay, and that value of resistor is actually function of the voltage that you have provided here, along with that the threshold voltage or the forward voltage of the LED. So every LED is going to have a forward voltage, and this forward voltage will be actually decided by the color of LED. So whichever LED you will use, you have to check the datasheet of that particular LED, and based on the color of that particular LED, the forward voltage of the LED will be decided. So for different color, for example red color, then for green color, then for blue color, so for all these colors the forward voltage of the LEDs are actually fixed. Okay, so now let's try to understand how to calculate the value of this current limiting resistor. Now, in order to calculate the current limiting resistor value, first of all, let's draw the equivalent circuit of this power LED section. So this is basically the equivalent circuitry of the power LED section. So this 5 volt I have represented with the help of this battery. So you can see the plus 5 volt terminal is connected to this end of the resistor. So this is the plus 5 volt which is connected to the one end of the resistor, and the negative terminal is actually connected to the cathode terminal of the LED. So you can see negative terminal of the ground terminal is actually connected to the cathode terminal of this particular LED. And this is basically the value of resistor which I have considered it as R, and we have to calculate the value of this particular resistor. Then this is basically the forward voltage of the LED that we are using. So as I told you, we have to check the datasheet of the LED. So you have to check the datasheet of this particular part number, and from the datasheet you will get the forward voltage value of the LED. So I have represented the equivalent model of this particular LED with the help of this battery which is connected in reverse direction. So this is actually the equivalent model of the LED, and I have represented the battery voltage as 2.8 volt because the forward voltage of this particular LED is actually 2.8 volt. Okay, so now let's calculate the value of this particular resistor. Now again, in the datasheet of the LED, it will be mentioned how much current or what's the maximum current that particular LED supports. Okay, so if you check the datasheet of this particular LED, then you will find that the maximum current that you can pass through this particular LED, it's actually 20 milliampere. So if you try to pass a current greater than 20 milliampere through this particular LED, then this LED will get damaged. Okay, so in all conditions we have to make sure that the current which is passing through this particular LED, it has to be less than 20 milliampere. Okay, so what I will do now, I am considering a current rating of 10 milliampere. So 10 milliamperes of current is going to pass through this particular LED. So I'm going to consider the value of I in this particular loop as 10 milliampere. So 10 milliampere is actually the current which will pass through this particular LED. Now what we will do, we will apply a KVL in this particular loop. So let's apply the Kirchhoff's voltage law in this particular loop. So the circuitry is very simple. So let's quickly apply the KVL. So we are going to get this particular equation after applying the KVL in this loop. So 5 minus IR. So I can write it as like this: IR minus 2.8 volt is equal to 0. And then I can simplify this equation by 5 minus 2.8 divided by the current that we have considered it as 10 milliampere, which is going to be 10 to the power minus 3. And this equation, after resolving this equation, we are going to get a value of R as 220 ohms. Okay. So that will be the value of the current, that will be the value of the resistor that we have to choose in order to pass a current of 10 milliampere through this particular LED. Okay. So that's how basically we calculate the value of the current limiting resistor that we need to connect in order to pass a specific value of current through the LED. Now when I placed the value of this current limiting resistor as 220 ohms in this particular circuitry, then the intensity of this particular LED was actually too high. Okay, and I didn't want the intensity of the LED to be that much high. So what I did, I increased the value of this particular current limiting resistor. So initially I used 220 ohms, then I went to 1 kilo ohms, then I went to 1.5 kilo ohms, and with the value of 2 kilo ohms, I was actually satisfied with the intensity of this particular LED. And that's the reason I have actually used a resistor with a value of 2 kilo ohms. And this method is actually called as trial and error method. Okay. So you can also use this particular method, in order to control the intensity of the LED, because you don't know at 10 milliamperes of current, what will be the intensity of the LED. So most of the time what you will have to do, you have to use this particular method, trial and error method, and by controlling the value of the resistor, you can check what's the intensity of the LED, and that's how basically you can finalize the value of the current limiting resistor. But this is basically the theoretical method to calculate the value of current limiting resistor. Okay, and I hope that now next time whenever you will get a particular LED and you will if somebody tells you that the maximum current that particular LED can pass or can sustain, it's basically 50 milliamperes, then what will be the value of the current limiting resistor. Okay, so you can do the calculation on your side. Okay, alright, so that's what I wanted to tell in this video. I hope that every single thing that we discussed is now clear to you related to this power LED section. And if you still have any kind of doubt, then definitely you can ask me and I will help you with that. Okay, and with that we have completed this part 3 of understanding the power supply circuit. And I hope that every single thing that we discussed in this 3-part series is now clear to you. Okay, alright, so that's what I wanted to tell in this video. Now I will see you in the next video, which is about the schematic design of power supply unit. Okay, so I will see you in the next video now.